If you think auxiliary equipment is just support hardware, this update will change your view because the next round of upgrades is all about control, sensors, and uptime. Fact.mr's report summary on the continuous casting auxiliary equipment market points to steady growth from about USD 3.9 billion in 2026 to about USD 5.8 billion by 2036, at around 4% CAGR. For foundry and die casting professionals, the bigger signal is this. Money is moving towards smarter process stability tools, not only bigger machines. So, what counts as auxiliary equipment in continuous casting? Think mold level measurement and control, breakout prevention, and mold monitoring, secondary cooling control, and the systems that keep a casting line stable through long runs. On steel lines, mold monitoring systems are built to detect risk early and prevent breakouts that can shut the caster down. And on mold level measurement specifically, radiometric systems are widely used in continuous casting because they can measure level reliably in harsh conditions. Now, why should a die caster care about what steel casters are buying? Because the same ideas are reshaping HPDC and gigacasting. Early warning signals, tighter closed-loop control, and fewer surprise defects. When continuous casting invests in better level control and monitoring, suppliers push sensors, analytics, and automation forward. Those capabilities often migrate into aluminum casting lines through temperature monitoring, cooling flow control, vacuum stability checks, spray consistency, and process dashboards. Here's the technical decode in Shopfloor language. In continuous casting, the mold is like the die entrance zone. If level swings, the meniscus becomes unstable. That drives surface defects, inclusions, and in worst cases, a breakout. So plants spend on auxiliaries that keep the metal level steady. Watch the mold condition in real time and manage cooling so the solid shell grows safely and consistently. Translate that to die casting. If your thermal balance shifts or vacuum drops or spray pattern drifts, you don't just get one bad part. You get a scrap wave, soldering risk, porosity shifts, and dimensional variation across the batch. Shopfloor takeaway for die casters. This week, pick one auxiliary and treat it like a critical process, not a utility. Start with cooling and spray. Verify flow rates line by line. Confirm nozzle health and log drift. Then add one simple alarm rule. If a key parameter moves beyond your normal band, stop and correct before you produce a full trolley of rejections. Small discipline, big impact. Quick recap. The market signal is clear. Auxiliary systems that protect uptime and stabilize quality are getting more investment. And that mindset is directly relevant to HPDC lines as they scale. My question for you, which auxiliary gives you the fastest scrap reduction in your plant? Thermal control, vacuum, spray, or shop monitoring? If you want daily die casting updates like this, consider subscribing.